Imagine looking up at the night sky and seeing stars that look tiny, though each is far larger than our sun.
Now picture a beacon 10 billion light-years away, shining brighter than entire galaxies combined.
This is TON 6188, a quasar powered by a supermassive black hole beyond ordinary understanding.
It radiates with the strength of 140 trillion suns, yet appears to us as only a faint dot.
Its light travels across 10 billion years of expanding space, weakening as the universe stretches it. By the time that light arrives, most of its energy lies beyond what our eyes can detect.
Think of a lighthouse, blinding up close, but barely visible from hundreds of miles away.
TON 6118 is that lighthouse, except scaled to the unimaginable size of the universe.
What we see isn't the black hole, but the superheated gas spiraling violently into it.
That gas heats to millions of degrees, glowing across every form of light we know. Imagine the energy of a star multiplied millions of times, released without pause.
Observing TON 6118 is like peering into a cosmic furnace operating on a galactic scale.
Yet in our telescopes, this titan shrinks to a single fragile pinprick of light. It reminds us how small we are and how vast the universe truly is. If we were closer, TON 6118 would outshine entire galaxies across the night sky. Its power could launch particle jets capable of sterilizing regions thousands of light-years wide. Thankfully, this giant sits far away, in a distant and safely isolated corner of the cosmos.
From that distance, its faint glow becomes a message carried across billions of years.
And from that tiny signal, we reconstruct a story older and grander than ourselves.
TON 6118 teaches us that the brightest objects often appear the most modest from afar.
TON 6118 is our reminder that the universe is bigger, older, and more wondrous than we imagine.
Imagine standing on Mars at night, watching Earth fade into a tiny pale blue spark in the dark sky.
Now picture something so massive that our entire solar system would look small next to it. TON 6118's event horizon stretches over 2,000 times the distance between Earth and the Sun.
If placed where our Sun is, its invisible edge would lie far beyond Pluto's frozen orbit. Our entire planetary family could fit inside it many times without touching the edges.
A black hole isn't an object, but a region where gravity becomes too strong for light to escape.
The event horizon marks the point where even light can't return, a boundary with no physical surface.
TON 6118 holds 66 billion suns worth of mass, compressed into a single gravitational well.
If the Sun were a pebble, this black hole would rise like a mountain, disappearing into the clouds.
Strangely, the gravitational stretching near its boundary is gentler than around smaller black holes.
Light would need weeks to travel from one side of TON 6118's horizon to the other.
For comparison, light from our sun reaches Earth in just over 8 minutes.
Now imagine TON 6188 appearing.
Orbits would collapse inward, pulled like leaves, spiraling into a powerful whirlpool. Its glowing disk would outshine everything, washing the sky in relentless light.
Thankfully, this monster lives over 10 billion light-years away, far beyond any danger to us. From that distance, its faint glow becomes a time capsule, carrying stories across ages.
By studying that small signal, we unlock clues about gravity, time, and cosmic evolution.
TON 6118 shows how tiny our solar system truly is next to the universe's giants. And it reminds us that the cosmos is deeper, older, and far stranger than we imagine. Imagine finding something in the universe so huge it no longer fits into our best scientific explanations. It carries the mass of 6 to 6 billion suns, far beyond what theory says a black hole should reach.
This breaks past the natural limit that normally keeps black holes from growing too fast. When a black hole feeds, radiation pushes back, preventing it from swallowing material too quickly.
Think of it like trying to drink too fast. The system pushes back before you can take in more. Yet TON 6118 somehow grew far past that limit, forcing us to rethink long-standing assumptions.
One idea says it may have formed from a gigantic collapsing cloud instead of a dying star. Another possibility is rapid mergers, black holes combining again and again in the early universe.
Some models suggest it may have briefly fed faster than the supposed universal speed limit.
A few East Asian male scientists even wonder whether TON 6118 began in the universe's first chaotic moments.
Whatever the path, TON 6118 pushes us to ask whether our theories are missing something vital.
It's a reminder that science isn't fixed. It grows whenever the universe surprises us.
TON 6118 stands as proof that the cosmos still holds mysteries larger than our expectations.
Imagine a lighthouse so powerful it doesn't light an ocean, but an entire corner of the universe.
TON 6118's quasar has been shining steadily for millions of years, without fading.
Its light began traveling toward us over 10 billion years ago, long before Earth even existed.
We're seeing a message from a younger universe, preserved across unimaginable distances.
Quasars form when matter spirals into a black hole and heats to millions of degrees.
That glowing disk becomes bright enough to outshine entire galaxies around it. Most quasars flare up briefly, but this one burns like a long-lived cosmic engine.
Imagine a bonfire hotter than thousands of suns, but never running out of fuel.
TON 6118 is powered by a black hole far larger than anything in our local universe.
Its enormous mass allows matter to flow inward in a steady, controlled spiral.
Instead of chaotic bursts, this quasar shines with disciplined, relentless energy. If you could stand nearby, the sky would be permanently lit by its glow.
Yet through our telescopes, TON 6118 looks like a tiny, quiet spark in the darkness.
Distance shrinks even the universe's brightest objects into modest little dots.
TON 6118 challenges our understanding of how long quasars can burn so intensely. Its persistence forces us to rethink what black holes and galaxies are capable of.
In a universe full of chaos, this quasar has shined with remarkable stability. Its glow reminds us that some cosmic wonders endure far longer than life on Earth.
TON 6118 is a cosmic lighthouse, its beam traveling billions of years to reach us.
And we're lucky enough to witness its ancient glow at exactly the right moment.
Imagine receiving a message not decades old, but 10 billion years old, carried by light across the universe.
That's what happens when we observe TON 6118, one of the universe's brightest and largest quasars. Its light began traveling toward us when the universe was just 3.3 billion years old.
If the cosmos were a person, this was its turbulent adolescence, messy, fast, and full of change.
Yet TON 6018 was already a giant then, holding the mass of 66 billion suns.
It's like finding a towering skyscraper in a town that hasn't even built its roads yet.
Black holes shouldn't grow this big, this early, according to our standard models.
Normally, they start small, feeding slowly, or merging over billions of years.
But TON 6118 seems to have skipped steps, growing faster than physics predicts. Some think it began from the direct collapse of a massive primordial gas cloud.
Instead of forming stars, the entire cloud may have plunged straight into a black hole.
Others suggest periods of supercharged feeding, devouring matter at extreme rates.
A few propose something wilder, a primordial black hole born moments after the Big Bang. Whatever the truth, TON 6118 grew in ways our models struggle to explain.
Its light began its journey before Earth, the Sun, or even the modern Milky Way existed.
That ancient beam crossed cosmic storms and galaxies before reaching our telescopes.
Astronomy lets us look backward in time, seeing the universe as it once was.
TON 6118 shows us that the cosmos learned to build giants earlier than we imagined.
It's more than a black hole. It's a message from a younger universe, calling us to explore deeper.
TON 6118 may have begun not as a star, but as a collapsing cloud of primordial gas.
Most black holes are born from dying stars, but this one may have taken a far more direct path. Picture a cloud so massive that gravity pulls everything inward before stars can even form. Instead of fragmenting into stars, the entire cloud may have plunged into one enormous collapse. It's the universe building a skyscraper without constructing the smaller buildings first. This direct collapse seed would start far heavier than any black hole born from a star.
With such a head start, TON 6118 could grow into a giant far faster than normal physics predicts.
The early universe was chaotic, hot, dense, and perfect for forming rare objects like this.
Radiation, gravity, and collapsing matter may have aligned to create a shortcut to a cosmic monster.
Some models suggest this process skipped stars entirely, diving straight into black hole formation.
Imagine watching a cloud millions of times more massive than our sun cave in silently.
At its center, a black hole would emerge already huge, shaping its infant galaxy. From there, feeding and mergers could quickly build it into the titan we study today.
TON 618's origins hint that the early universe may have built giants faster than we imagined.
It challenges our models and reminds us that cosmic history is full of unexpected shortcuts.
Even billions of years later, its light carries clues about those ancient, turbulent beginnings.
TON 6118 shows that the universe is still teaching us how its largest structures were born.
Imagine galaxies colliding like waves meeting at sea, creating something larger than either could alone.
This may be how TON 1618 began, born from repeated mergers of growing black holes.
In the early universe, galaxies weren't calm cities. They were chaotic construction zones.
When galaxies collide, their central black holes almost always meet and eventually merge.
Each merger adds mass, building a black hole faster than steady feeding ever could.
Picture this happening again and again as young galaxies smash together. With every collision, TON 618's ancestor grew larger, like a snowball gaining momentum.
These mergers would have sent powerful ripples through space-time itself.
The early universe was dense enough for these events to happen surprisingly often.
Black holes merged, galaxies reshaped, and cosmic giants began to take form.
TON 6118 may be the final product of dozens of these ancient cosmic collisions.
Imagine black holes merging so violently that entire galaxies felt the impact. Each merger pushed TON 618 closer to becoming the monster we observe today.
These events may explain how it grew so huge so early in cosmic history. It challenges our models and reminds us the young universe was far more violent. TON 6118 is more than a black hole. It's a fossil of cosmic turbulence.
Its light carries the memory of a universe still building itself through collisions.
TON 118 shows us that cosmic giants are often forged through extraordinary violence.
Imagine a black hole growing so fast it seems to ignore the universe's natural speed limit.
That limit is called the Eddington barrier, normally the braking force that slows a black hole's feeding.
When matter falls in, it heats up and pushes back with intense light, creating a balance.
But TON 618 appears to have slipped past that balance, swallowing material faster than expected.
It's like watching water pour into a bottle faster than the opening should allow.
In the early universe, conditions were extreme enough to make this possible. Gas was abundant, collisions were frequent, and black holes had plenty to feast on. Some flows may have funneled matter inward so efficiently that radiation couldn't push it back. Gravity, magnetism, and dense gas layers might have aligned to break the usual limit.
Even brief periods of this runaway feeding could help explain TON 618's immense size.
It suggests that the early universe was far more extreme than our models once assumed.
TON 6188 challenges the idea that black holes grow at predictable, steady rates.
Instead, it hints at rare moments when nature bends its own rules.
Its ancient light carries the memory of those extraordinary feeding events.
TON 6118 shows us that the universe isn't just vast. It's far more daring than we imagine.
Imagine rewinding the universe to a time before the first stars ever formed.
Some physicists believe TON 618 may come from that ancient, starless era.
These objects are called primordial black holes, born from early cosmic density spikes. Instead of forming from dying stars, They emerged directly from the universal's first fluctuations.
Such a black hole would start life far heavier than typical stellar remnants.
TON 60118 may have had billions of years to grow, beginning long before galaxies matured.
Its enormous mass suggests it might have had a head start from the very beginning.
Picture the universe's first moments. Hot, dense, and filled with violent fluctuations. In that chaos, gravity could have collapsed certain regions instantly into black holes.
If TON 618 began this way, its early growth suddenly becomes easier to explain.
Primordial black holes might even help explain mysteries like dark matter.
TON 6118 challenges us to consider whether such ancient objects still survive today.
Its behavior doesn't fit neatly into the story of black holes born from stars.
Instead, it hints at origins tied to the universe's first heartbeat.
Every photon from TON 6118 may carry a message from that primitive era.
If it is primordial, TON 6118 is one of the oldest relics in all of cosmic history.
Imagine a galaxy so intense it acted like a cosmic furnace, forging a black hole beyond anything we expected. TON 6818 likely didn't grow in calm conditions. It needed chaos and overwhelming fuel.
Its enormous mass hints that its host galaxy once burned with extreme activity.
Picture a galactic core where gas collapsed rapidly, feeding the black hole like a raging river.
Under normal physics, radiation pushes back and slows the feeding process.
But TON 6118 seems to have swallowed matter faster than that natural break could stop. Its galaxy may have created conditions so extreme that limits simply bent under pressure. Collisions, dense gas clouds, or gravitational instabilities could have fueled the frenzy.
The result was a black hole growing at a pace that feels almost frantic.
It's a sign that early galaxies were far more violent than those we see today.
TON 6118 is a fossil of that cosmic violence, a reminder of extreme conditions long gone.
Its light today carries the memory of a galaxy once burning at full cosmic throttle.
Imagine parts of the universe where invisible matter collects so densely it reshapes everything around it.
Simulations suggest TON 618 sits in one of these extraordinarily dense regions.
Dark matter acts like a hidden landscape, guiding normal matter into its deepest wells.
In these rare pockets, gravity becomes so strong that galaxies form faster and collide more often.
A black hole growing in such a place wouldn't sip material, it would drown in it. TON 618 likely fed on constant inflows shaped and funneled by dark matter around it.
It's the cosmic equivalent of opening a restaurant in a city of millions. Growth becomes inevitable.
These regions create gravitational engines powerful enough to build giants quickly.
Without this dark matter density, TON 68 could never have grown so huge so early. It reminds us that dark matter isn't just background, it's the architect of cosmic giants.
TON 618 is a signpost marking one of the universe's most extreme neighborhoods. Its ancient light carries the fingerprint of dark matter's deepest structures.
Imagine jets from TON 6118 blasting through its galaxy with the power of cosmic fire hoses.
These jets could stretch hundreds of thousands of light years across space.
When such a jet hits a gas cloud, it can either scatter it or squeeze it tightly.
If the gas heats too much, star formation shuts down entirely.
But if the jet compresses the gas just right, it can trigger new stars to form.
TON 6118 may have reshaped its galaxy, deciding where stars could or couldn't be born.
Some regions may have been blasted clean, left barren for billions of years.
Others may have ignited in brilliant bursts of star formation.
Its jets weren't gentle. They were engines of change on a galactic scale. TON 6118 shows how a single black hole can sculpt an entire galaxy's destiny.
TON 6118 shines with unimaginable power, yet Webb sees it as only a single point of light.
Its photons traveled more than 10 billion years just to reach our telescope. By the time this light began its journey, Earth and the Sun didn't even exist.
Even Webb, built to reveal the earliest structures, can't resolve TON 6118's details. Its brightness suggests complexity. But
it's a reminder that our view of the cosmos is still incredibly narrow.
TON 6118 looks isolated not because it's alone, but because we can't yet see its surroundings. Studying its light is like hearing an echo from a distant explosion and trying to decode its story. Every pixel we capture is a doorway into a universe we barely understand. TON 6118 reminds us that even the brightest giants can appear small in the universe's vastness. Studying TON 6118 shows us that a black hole and its galaxy evolved together, shaping each other over billions of years.
As a black hole feeds, it releases energy that spreads far beyond its tiny core.
That energy can heat or scatter gas, changing where new stars can form.
Sometimes it quenches star formation, leaving regions quiet and empty.
Other times, it compresses gas just enough to spark new stellar nurseries.
The galaxy feeds the black hole, and the black hole reshapes the galaxy.
This feedback loop helps explain why massive galaxies look the way they do today.
TON 6118 highlights that even a compact object can influence billions of stars.
Its extreme growth hints at a turbulent past, filled with rapid star formation and violent outflows. In studying TON 6118, we learn that no galaxy evolves alone. Its heart and its body grow together. TON 6118 is so massive that it forces us to rethink how the universe builds its largest structures.
It grew too fast and too early to fit neatly into our standard cosmic timeline.
It's like finding a skyscraper fully built, while the rest of the city is still just foundations.
Its existence hints at the early universe was far more dynamic and uneven than we imagined.
Maybe some regions had extraordinary densities, allowing black holes to grow at incredible speeds. Or perhaps giant clouds collapsed directly into black holes, skipping stars entirely. Some even suggest TON 6118 could be a relic of the universe's earliest moments.
Whatever its origin, TON 618 challenges our models of how galaxies and black holes evolve.
It reminds us that the cosmic blueprint may be far more flexible than we assumed.
TON 618 shows that the universe is still capable of surprising us on the grandest scales.